Hello students. In this session for B.Sc Chemistry, first semester and session is 59. So let us discuss about stoichiometry and other topic about mole concept and also problems on mole concept. So prerequisites for this, we are going to discuss about atomic mass, you should know, molecular mass and also STP, that is at standard temperature and pressure. So let us know what is mole and Avogadro number. Mole, it is defined as the number of atoms present in exactly 12 grams of carbon, that is carbon 12 isotope. So it is the unit of quantity of a substance. Na, that is Avogadro number, is denoted by capital A and subscript A, capital N and subscript A, which is given by 6.02 into 10 to the power 23. It is the collection of 6.02 into 10 to the power 23 particles of a substance. So, 1 mole of any substance contains 6.02 into 10 to the power 3 particles. In other words, 1 mole of an atom, if you take, it is equal to 1 gram atomic mass of any element, means Avogadro number of atoms. Similarly, 1 mole of a compound means it contains Avogadro number of molecules or 1 gram molar mass. So, in turn, mole is defined as the amount of substance that contains Avogadro number of particles or Avogadro number of atoms or ions or molecules, etc. So, 1 mole of carbon means it contains 12 gram. In turn, it contains 6.022 into 10 to the power 23 atoms. Suppose if you consider 1 mole of methane, that is CH4, which contains 16 gram, that is carbon is 12 plus hydrogen is 4 into 1. So 16 plus 4 is, 12 plus 4 is 16 grams, which in turn is equal to 6.022 into 10 to the power 23 molecules. Suppose if you consider for 1 mole of gas, it occupies 22,400 cm cube per 22.4 dm cube volume at standard temperature and pressure. So to calculate the number of moles, let us follow these formulas. Number of moles is equal to mass in gram by gram atomic mass. Similarly, number of moles may also be equal to mass in gram by gram molar mass. Similarly, number of moles of a gas, we can write it in this way, that is, volume of a gas occupied at STP in cm cube per dm cube per 22,400 cm cube per 22.4 dm cube. So, number of molecules of a substance, we can write it as mass in gram by gram molar mass into 6.022 into 10 to the power 23. Similarly, number of molecules, it can be written as number of moles, this is nothing but number of moles, into 6.022 into 10 to the power 23. Similarly, if you consider atoms, number of atoms in a substance, it is number of moles into atomicity into 6.022 into 10 to the power 23. Number of molecules in 1 gram of a substance, it is given by 6.022 into 10 to the power 23 by molar mass. So similarly, mass of 1 molecule in grams, it can be written as gram molar mass by 6.022 into 10 to the power 23. So here we can relate number of moles, that is n, small n, and number of particles, that is capital N, and weight in grams, W, in this way. That is, number of moles is, if you multiply with Na, that is Avogadro number, you will get number of particles. So this number of particles, if you divide by Na by mm, you get weight in grams, that is W. So here mm is nothing but it is molar mass. And we know Avogadro number is equal to 6.023 into 10 to the power 23 particles. And weight in grams, if you divide by molar mass, we get number of moles, that is small n. Or this number of moles, if you multiply by molar mass, we get weight in grams. Now let us pass on to the problem. Let us try to solve one or two problems. How many moles of water are present in 720 gram of water? So number of moles we know very well, it is mass by gram molecular mass. Let us calculate molecular mass of water, H2O. So for oxygen it is 16 plus H2, it is 2 into 1, 2. So 16 plus 2 is 18. So molar mass or molecular mass of water is 18. Similarly, gram molecular mass of water is 18 grams. Therefore, 1 mole of water is equal to 18 gram, and number of moles of water is equal to 720 gram by 18 gram. It is 40. Similarly, let us look into another problem. Calculate the number of molecules in 4.25 gram of ammonia. Number of molecules of ammonia is given by number of moles into 6.022 into 10 to the power 23. So molecular mass of ammonia is 17. That is, for nitrogen it is 14, plus for hydrogen 3 into 1 is 3. 14 plus 3 is 17. So gram molecular mass of ammonia is 17 gram, which in turn it is equivalent to 1 mole of ammonia. Therefore, number of moles of ammonia is 4.25 gram by 17. We get 0.25. That is, this is number of moles of ammonia. Therefore, the question is number of molecules. Therefore, number of molecules of ammonia is 0.25 into 6.022 into 10 to the power 23, which is equal to 1.5 into 10 to the power 23. Let us look into one more problem. What is the mass of one molecule of sulfur dioxide? Mass of one molecule in gram is gram molar mass by 6.022 into 10 to the power 23. So you should able to know, you should learn these formulas. So gram molecular mass of sulfur dioxide is given by 64 gram, that is molecular mass of sulfur dioxide, which in turn it is 1 mole of sulfur dioxide. Then mass of one molecule of sulfur dioxide is 64 by 6.022 into 10 to the power 23, which in turn it is equal to 10.6 into 10 to the power minus 23 gram. So summary is, in this session we discussed about mole and Avogadro number, and also we learned how to calculate the number of moles in some of the problems. So references, what you can made is Bhal A, Bhal BS and Thuli GD. That is, the textbook is Essentials of Physical Chemistry. You can also refer Principles of Physical Chemistry by Puri, Sharma and Patania, and a textbook of Physical Chemistry by Negi AS and Anand SC. So you can also refer other physical chemistry textbooks for this session. So this is digital learning. Department of Collegiate Education is presenting these videos for you. Thank you.